In this video, we are going to go through problems 1 and 2 in chapter 4 of our book. So problem number 1 says the following payoff table shows a profit for a decision analysis problem with 2 decision alternatives and 3 states of nature. Our first task is to construct a decision tree for this problem. So remember, the decision tree is different from an influence diagram because in a decision tree, we actually include the payoff at the end of the branches. So decision trees and influence diagrams include squares, which are our decision nodes, and circles, which are the chance nodes. So what we're going to do is we are going to figure out what we need where, and then we write all of our information on the branches. So we can start out drawing one square, and off of that square, or that decision node, we have 2 decision alternatives. We have D1 and D2. Then, for each of those decision alternatives, they have the option of any of the 3 states of nature. So we put 2 circles to represent that we're going from the decision node over to the chance node. And off of each of the chance nodes, we know that we could have state 1, state 2, or state 3. That's the case with each of the 2 decision alternatives. S1, S2, S3. Then the last piece of information that we need to put on here is the actual payoff. So if we look at our table that we're given, if we go to decision alternative 1 over to state of nature 1, we're told that that has a payoff of 250. State of nature 2 has a payoff of 100, and 3 has a payoff of 25. Then we move down to alternative 2 and put in the information that we're given in our table there. So this concludes the decision tree. These are all of our options. You could easily follow the path from the beginning through the states of nature and determine what your payoff would be. Now part B says if the decision maker knows nothing about the probabilities of the 3 states of nature, what's the recommended decision using the optimistic, conservative, and minimax regret approach? So first, the optimistic approach, that is simply what's the best? What can get us the most money? So we look through here, we find our largest payoff, and that's 250. That goes along with decision alternative 1. So the optimistic approach, we would end up going with decision alternative 1. Now the conservative approach, that's the best of the worst. So we want to look through here, figure out what's the worst payoff, what's the least that we could get. Well, if we went with alternative 1, the least is 25. Alternative 2, our smallest payoff would be 75. But conservative approach is best of the worst. So the best between 25 and 75 is going to be the $75 payoff. So that goes along with decision 2. Now the minimax regret approach takes a little more work, but it's helpful to create another table. So what we're going to do is we are going to list our decision alternatives again, D1, D2, and we will list our states of nature. But the minimax regret takes a look at what we could have gotten and what we actually got. So first we need to go through and fill out our numbers. You look at each state of nature. So in state of nature 1, the best number there, the highest number, the best we could get would be 250. So decision alternative 1, if we got 250 and we could have gotten 250, the difference or the amount we missed out on was 0, nothing. We got it all. However, if we had state of nature 1, but we chose decision 2, we only got 100 when we could have gotten 250. So 250 minus 100 is a difference of 150. Now we need to go over and look at state of nature 2. Here in decision 1 and decision 2, we got $100. So either way, we got 100. The most we could have gotten with that state of nature was 100. So we didn't miss out on anything regardless of the decision that we chose. State of nature 3, the best number there, the best outcome would be decision 2, 75. However, if we chose decision 1 and we only got 25, but we could have gotten 75, we missed out on 50. Now, if we did choose decision 2 and we got 75 and the max we could get is 75, then we missed out on 0. So then we take a look and we want to figure out, give yourself another column here, we want to look at each decision and figure out the max regret or the most we could have missed out on here. So in decision 1, the most we would miss out on is 50. Decision 2 is 150. Then of the maximums, we choose the minimum. So minimum of the maximums is 50. Decision 1 is the choice under mini-max regret. So mini-max, decision 1. Moving on to problem number 2, we're given another table. Suppose that a decision maker faced with 4 decision alternatives and 4 states of nature develops the following profit payoff table. So we have our 4 decision alternatives and our 4 states of nature. If the decision maker knows nothing about the probabilities of the 4 states of nature, what's the recommended decision using the optimistic, conservative, and mini-max regret approaches? So again, just like what we did in part B of number 1. Optimistic, this is a profit payoff table, so this is what we're going to make, the money that we're going to get. Optimistic is going to be the largest number that we see here. The biggest number is 14. That goes along with decision alternative 1. So optimistic, you would choose. Now with the conservative approach, we want to pick the best of the worst. So we would look at decision alternative 1. What is our worst payoff? That goes along with state of nature number 4 or 5. So decision alternative 2, what's the worst we could get? 7. Decision 3, we could get 9, or decision 4, the worst is an 8. Now we want the best of the worst. So the best payoff, the highest payoff here, is the 9 that goes along with decision 3. Now we want to go ahead and calculate the mini-max regret. So again, let's construct a table for ourselves. So we are creating a very similar table to what we have above, but we have to perform our calculations, figure out what we could be missing out on. So 4 decision alternatives, 4 states of nature. If we look at our state of nature, we need to figure out what's the best and then what are we missing out on. So state of nature 1, the most we could get is 14. If we went with decision 1 and we got 14, but the most we could get is 14, 14 minus 14 is 0, we're not missing out on anything. However, if we went with decision alternative 2 and state of nature 1, we only got 11, but we could have gotten 14, so we missed out on 3. 14 minus 11 is 3. If we had gone with decision 3, 14 minus 9 is 5. Decision 4, 14 minus 8 is 6. Now go ahead and pause the video. I want you to try to fill out the remaining 3 columns and see what you end up with. Then after that, we will go ahead and look at the max values together. So hopefully your numbers match up with mine and you were able to fill out the rest of your table. Now we need to take a look and figure out what is the maximum value that goes along with each decision alternative. So if we look at decision 1, our max value is 8. Decision 2, the largest number, the max value is 6. Decision 3, 5, and decision 4, our max value is 6. So now remember, we want the minimum of the maximum regret. So if we're going to regret something, we want to have the minimal amount of regret. That goes along with 5. 5 is the least number here, the smallest number we see. That goes with decision number 3. So mini-max regret method, we would choose decision alternative 3. Now take a look at part B in your book. Your answers will vary a bit, but it's a good idea to think about what you would actually use. Part C we'll do together, and it says, assume that the payoff table provides cost rather than profit payoffs. So what's the recommended decision using optimistic, conservative, and mini-max regret approaches? So now we're looking at cost. When you think about how much you want to pay for something, we obviously want to pay the least amount possible. We want to get a good deal. So now instead of looking for the largest numbers, we want to look for the smallest number. So in the optimistic approach, we look at the entire table, find the smallest cost. So the least amount that we could pay here is 5, and that goes along with decision alternative 1. Then we want to look at conservative, the conservative approach. So remember, that's the best of the worst. So we have to figure out what the worst scenario is for each decision alternative. Then we're going to pick the best one of those. So go along the row, and the worst for decision alternative 1 would be 14. That'd be paying the most money. Then here we have an 11, 11, and 13. So in the conservative approach, you can see that we have an 11 for decision alternative 2 as well as decision alternative 3. So with the conservative approach, you could choose either decision 2 or 3. Now we need to build our minimax regret table. So remember, we're dealing with costs, not profit. So you need to flip your way of thinking. We want small numbers instead of big numbers. And we're working within the states of nature first. So looking down state of nature 1, the best case scenario would be if we only paid 8. So let's start with decision alternative 4. If we only paid 8, and we could have gotten away with just paying 8, 8 less 8 is 0. There was no missed savings there. Now, if we move our way up from the bottom, if we paid 9, but there was an option to only pay 8, we overpaid by 1. With decision alternative 2, if we paid 11, but again, at some point we could have paid 8 instead of 11, then we missed out on 3. And decision alternative 1, we would have overpaid by 6. So again, I suggest pausing the video, trying to fill out the rest of the table here, then push play when you're ready to create this or fill in this maximum column together. So check your numbers here with mine, make sure that they match up. Now we want to go ahead and fill out our maximum column. What's the maximum amount of regret we could see with each of these decision alternatives? So if we go along with decision alternative 1, the most we could have overpaid by was 6. 2, our max is 3. Decision alternative 3, max is 6. Decision alternative 4, max is 8. So again, we want to minimize this. We want to overpay by the least amount possible. So our smallest number here is 3, goes along with decision 2. Minimax regret approach, we would choose decision 2. I hope this was helpful for you guys.